When reading a pedigree, it is important to distinguish between two categories. First, is the trait dominant or recessive? Second, is the trait autosomal or sex-linked? Autosomal traits are located on non-sex chromosomes, while sex-linked traits are on one of the sex chromosomes. In autosomal traits, males and females are affected in equal proportions. In sex-linked traits, it is more probable for males to be affected than females.
Autosomal dominance is a way to transfer genes or diseases. In terms of diseases, it requires only one abnormal gene in either parents to create a disorder in the offspring.
Autosomal recessive is one of several ways that a disorder or disease can be passed down through families. It also means that two copies of an abnormal gene must be present in order for the disease or trait to develop. For example, if a parent carries the gene but don't have signs of the disease, the child will have a 25% chance to inherit the normal gene, and there is a 50% chance that the child will inherit only one normal gene and one abnormal gene from both parents. This will make the child a carrier, but the child will not have the disease. The last 25% is the child being born with two abnormal genes from both parents, and this will put the child in a risk for developing the diseases that the parents are the carrier of.
As shown in the diagram, if an affected male have children, his daughters will all be affected because the daughters will receive the affected X chromosome from the father, but no sons will be affected.
This pedigree depicts a sex-linked trait on the X chromosome. Here, only males are fully affected. One example of sex-linked recessive traits is colorblindness, where the gene is found on the X chromosome. Males have only one X chromosome, whereas females have two, so it's more probable for a male's single X chromosome to contain the faulty gene than both of a female's X chromosomes.
To summarize, pedigrees allow scientists to analyze patterns of trait inheritance through biological relationships. This can allow one to see how certain alleles have been inherited in order to anticipate future inheritance. This is very helpful because it can show potential for diseases, disorders, or characteristics. Thanks for watching!